Example, find the absolute extreme values for f of x equals x divided by x squared plus 5 on the closed interval from 4 to 8. Notice that for this function, the domain of f is all reals even though you have a variable in the denominator. And that's because that variable is squared, then you have plus 5. We need to find critical values. And critical values occur where the derivative equals 0 or the derivative is not defined. Regardless, we have to find the derivative. And to find the derivative, we're going to use the quotient rule. Remember, the quotient rule is if you have a high function divided by a low function, that derivative is the low squared in the denominator, and you have low d high, meaning the derivative of the high, minus high d low, meaning the derivative of the low. Let's use that rule. The denominator is x squared plus 5, and we square it. Now, we write the low function, which is x squared plus 5, take the derivative of the high function x, which is 1, minus, we write the high function, which is x, and multiply it to the derivative of the denominator. The derivative of x squared plus 5 is 2x. The numerator becomes x squared plus 5 minus x times 2x would be 2x squared. The denominator is still x squared plus 5 squared. Simplified a little bit, and the numerator can be expressed as 5 minus x squared divided by the quantity x squared plus 5 squared. In order to have a fraction equal 0, the numerator has to equal 0. That is, we want the numerator to equal 0. You write 0 equals 5 minus x squared, and solving for x squared equals 5, we're going to use the square root property. The critical values are x equals plus or minus the square root of 5. Since neither of the critical values, x equals negative the square root of 5 or x equals the positive square root of 5, is in the closed interval from 4 to 8, so we evaluate the function at just the endpoints. That is, when x is 4, evaluate 4 in the original function. I used a calculator, and the output was approximately 0.19, and the other endpoint, 8. Evaluate the function at 8. I used my calculator, and the output was roughly 0.116. 0.19 is larger than 0.116. So we have an absolute max at x equals 4 of 0.19. At 4 of 0.19. And we have an absolute min at x equals 8 of the value 0.116.